In our lesson on the periodic table, we learned about the group of elements known as the alkali metals, that is, the group 1 elements. As seen from the periodic table displayed here, one of the members of this group of elements is sodium. In this lesson, we will discuss the occurrence and the method used for the extraction of sodium. Apart from being in the alkali metals in the periodic table, sodium is also the most common alkali metals found on Earth. And since sodium is a very reactive metal, it is not found naturally in its free state. Instead, it is found in combined state in many compounds. If you are asked to mention a compound of sodium that you are very familiar with, what would it be? I have no doubt that you'd probably mention sodium chloride, which is the salt we use in cooking food. This is because sodium chloride is the most important and most familiar compound of sodium. In fact, it can be found in seawater and rock salt. And sodium chloride is the compound from which sodium is extracted commercially. Now let's discuss how sodium is extracted from sodium chloride. As explained in our lesson on the metal extraction principle, the method employed in the extraction of a metal depends on the chemical reactivity of the metal. The method could be thermal or electrolytic reduction. Since sodium is a very reactive or a strongly electropositive element, it means that it cannot be extracted using thermal reduction. It is extracted using electrolytic reduction instead. The electrolytic cell used for the extraction of sodium is called the down cell. Here is a simple diagram showing the structure of a down cell. The cell is designed to produce two products which include sodium and chlorine gas. The cathode of the cell is a steel or iron cylinder, while the anode is central graphite. The electrolyte used is molten sodium chloride, which is mixed with calcium chloride. The calcium chloride is added to keep the electrolyte molten by lowering the melting point of sodium chloride from 801 degrees Celsius to about 600 degrees Celsius. This makes the process more economical. At the anode, the chlorine ions in the electrolyte are discharged, and this leads to the production of chlorine gas at the surface of the electrode. While at the cathode, the sodium ions in the electrolyte are discharged to form molten sodium, which floats to the surface of the electrolyte. As shown in the image, the molten sodium produced in the cell is then collected in a storage tank. The collection of the molten sodium and chlorine gas from the cell is possible because the steel diaphragm or iron screen prevents sodium from mixing with chlorine. Here is a summary of the key points from this lesson. Sodium is the most common alkali metal found on Earth. Sodium chloride is the most important and most common compound of sodium. The electrolytic cell used for the extraction of sodium is called the down cell. Molten sodium and chlorine gas are collected from the cell during electrolysis. And so we will end this lesson here. I'll see you again soon. Goodbye.